Morning once again. We are now entering another chapter of our class. We are now going to chapter 4. So for those who have turned in their test, thank you. And for those who haven't turned in their test, I don't know what's wrong. I hope you're able to do all your requirements because I can only compute what you will give me. If you don't give me anything, so I don't have anything to compute for your grades. Okay, so chapter 4. Chapter 4 is the beginning of a series of chapters that will talk about triangles. So we'll have chapter 4 and chapter 5. These two consecutive chapters will talk about triangles. So chapter 4 is entitled, even chapter 4 is entitled Congruent Triangles. Okay. So we'll start with the first lesson of chapter 4, which is classifying triangles. So classifying means grouping. How do we group triangles? How do we identify triangles? Or how do we name triangles? So there are two main options in classifying triangles. We classify triangles by angles, or we classify triangles by sides, and we can combine both when we try to name a triangle based on angles and at the same time based on the sides. So we all know these three types, the common types of angles. We have the acute, obtuse, and right. So we use this also, these three terms in classifying triangles by angle. So this refers to the measurements of the angles of a triangle, the interior angles of a triangle. So when we say acute triangle, these are triangles wherein all interior angles measures less than 90 degrees. All angle measures is less than 90 degrees. Okay, so we call it acute triangle. The next one is obtuse triangle. An obtuse triangle is a triangle wherein one angle measure is greater than 90 degrees. One angle measure is greater than 90 degrees. So you don't expect to have more than one because it's impossible. And later you found out why it's impossible to have two angles with more than two angles with the whose measurement is greater than 90 degrees. And the last one is the right triangle. The right triangle is a triangle wherein you see a 90 degrees angle. Okay, either you're given with a number 90 degrees on the triangle, or like what we used to before, if there is the square, if you see that square symbol on the angle on the corner of the vertex of the angle, then that means that that angle is 90 degrees. So if there's a square corner, or if there's a corner that has a square, then that pertains to 90 degrees, then the whole triangle is considered as a right triangle. And we have a special type of triangle. We call it, acute triangle. We call it equiangular triangle. So equi means equal, equal angle. So an acute triangle with all angles congruent is an equiangular triangle. So in an equiangular triangle, you'll see that all angles are equal and each of them is equal to 60 degrees. So each of them is 60 degrees. When we say that it's equiangular automatic, each angle measures 60 degrees. Okay, always remember that we are referring to three interior angles within a triangle. Of course, a triangle has three sides. It also has three angles. So we are only talking about the three angles within a triangle. So each of them is 60 for equiangular triangle. Next is you can also classify triangles by sides. So this is not talking about the measurement, the exact measurement or the numbers that represents the measurement of a side. Rather, we classify triangles by sides based on the number of congruent sides it has. Okay, so based on the number of congruent sides they have. Okay, so first we have scalene triangle. Okay, scalene triangle is when no two sides of a triangle are congruent. That means the three sides of a triangle have different measurements. They all have different measurements. So no two angles, no two sides are congruent. And then we have isosceles triangle. Okay, I know you're familiar with these terms. This is not the first time that you heard these terms. Next is isosceles triangle. So isosceles triangle is when you have at least two sides that are congruent in a triangle. So if there's two congruent sides, then we call it isosceles triangle. But if there's three, although it's still fitted to the definition of isosceles, but we have a more specific name for that. If all the sides of a triangle are equal, so the three sides are equal, then we call it equilateral triangle. So all of the sides of an equilateral triangle are congruent. So the three sides have the same measurement. Okay, so this is like in a four-sided polygon, quadrilateral. This is equivalent to a square. Okay, a square has four sides and all the sides are equal. On a three-sided polygon in a triangle, if all the sides are equal, then we call it equilateral triangle. And we go back to this equiangular triangle. Once a triangle is equilateral, it is also called equiangular triangle. Or once it's equiangular, it's also called equilateral triangle. So the equiangular and the equilateral goes together. Okay, they go together. Okay, so we can classify triangles based on the angles and based on the sides. So in that way, we can even name the angle using both classification. You can say acute scalene triangle, or you can say obtuse scalene triangle, or you can say right scalene triangle, or acute isosceles triangle, or obtuse isosceles triangle, or right isosceles triangle. Okay, but for equilateral, it's always acute because all of the angles are 60 degrees. None of them can be greater than 90, and none of them is equal to 90. So for equilateral, we can only say equilateral triangle, and it implies it's acute. Okay, or acute equilateral triangle. That's very specific already. But if you say equilateral, it can never be obtuse, it can never be right. It's understood to be acute. Okay, so let's now go on in finding, using those properties of triangle classification in solving problems here. So we have here algebra problem. Find x and the measure of each side of equilateral triangle. So we have to make use of, or we have to take note of the terms used, because those terms will give us an idea on what kind of problem we are dealing with. Okay, so in number 3, we're dealing with equilateral triangle. So equilateral triangle RST. So it is a triangle whose all sides are equal. And so since triangle RS is equilateral, then we can say that RS is equals to ST. But not only that, okay, not only we can use RS and ST, we can also say RT is equal to ST, or RT is equal to RS. So if it's equilateral, you can have 3 options, okay? 3 options, not only RS and ST, you can also say RT is equal to ST and RS is equal to RT. So aside from RS equals RT, we can choose RT or RST, or RS or and RT. Okay, but we cannot say RS is equal to ST equals to RT. That's just a statement, but cannot be used as an equation. There's no such thing as equation with 2 equal sign. That would defeat what we have discussed before, what you have learned in algebra, wherein you have the left side of the equal sign and the right side of the equal sign. So there's only one equal sign that you should have in one equation, okay? Although the 3 sides are equal, RS, ST, and RT, or RS is equal to ST is equal to RT, that only gives us an information that you can pick any 2 sides from these 3 sides and put equal sign between them. And after you put equal sign between them, then you do the algebra of the equation that you have. For example, here, x plus 9 is equals to 2x. So solve for x, minus x both sides, so x is equal to 9. So now, it says find x and the measure of each side. So it's not just x, but also the measure of each side. So we're dealing with triangles. We're dealing with a triangle. Therefore, we are tasked to find the three sides of this triangle. Okay, not only the x. So although we know that all of them are equal, but it is best if you want to solve them one by one, so it validates also whether the value of the x that we have is correct or not. But if you are very confident with the x that you have solved, also, you can just say rs equals to x plus 9. Your x is 9, so 9 plus 9 is 18, and then you can say st equals to 18, and rt is also equal to 18 because you already know that the three should be equal. But for checking purposes, you might want to you have to you can replace the x on each of the other two sides and see if you all end up to have the same, if they all end up having the same answer. So rs is 18, st is 18, rt is also 18. So that validates your answer that x is correct, which is equal to 9. Because if your x is not correct, when you replace it to your rs, to your st, and to your rt, they will give you different answers. Okay, it will give you different answers. So that means you may choose to solve them one by one, or you just want to solve one and then say st equals to 18, rt equals to 18. You have to write it separately. You don't write your answer as rs equals 18 equals st equals rt. Okay, you have to separate. You have to write your answer in three separate statements. rs equals to 18, st equals to 18, rt equals to 18. Okay, so let's solve now the check your progress. Okay. Find x and the measure of the unknown sides of isosceles triangle EFG. So find x and the measure of the unknown sides of isosceles triangle EFG. What kind of triangle do we have here? It's said to be isosceles triangle. So take note that an isosceles triangle has two equal sides. So that means we have to be very careful on checking what are the two sides that are equal here, because that's the only two sides that we can use with an equal sign in between them to solve for the value of the variable. Okay, so we look at the figure. In the figure, we're given with the figure, it's given that EF and FG are congruent because of these indicators. Okay, these small lines on the side that tells us that these two sides are equal. And so the only way to solve for x is to use EF and FG. So EF is equal to FG. Okay, so what is EF for x equals to FG? What is FG? 2x plus 6. Okay, so solve for x, minus 2x both sides. Okay, for the sake of those who are still confused of algebra, but still you don't wonder why you pass algebra 1, but you're still confused of solving this. Okay, minus 2x both sides because we want to take out this positive 2x. And so we minus 2x, and whatever you put on the right side or one side, you have to put it on the other side, the same thing on the other side. So that's why there's there's minus 2x on both sides of the equation. And after that step, that would result into 2x equals 6. And then divide to both sides, x is equal to 3. So x is equal to 3. Okay, it says in the measure of the unknown sides. Why? Why unknown sides? Because one of the sides are already given to be 14. So it's time for us to solve for the two sides who has a variable x or which is represented by an expression. So EF is equal to 4x. Your x is equal to 3. So 4 times 3, and so it's equal to 12. So EF is equal to 12. What about FG? So FG is equal to 2x plus 6. So FG is equals to 2x plus 6. So what is your x? Again, our x is 3. So we replace that x to the 3 to the x. So 2 times 3, 2x plus 6. Okay, so that gives us, yes, I say, so it's 6 plus 6, and then it's equal to 12. So FG is equal to 12, and here EF is also equal to 12. So you see, we are expecting these two to be equal because they are the two sides that are equal. And because our x is correct, it gives us the same value for EF and FG, which is 12. Okay, again, if you replace the x and the two sides does not end up to be the same, then either the way you replace the x is wrong or your x itself is wrong. Okay, so these are very easy equations that we're making. We're just writing an equation by putting equal sign between the expressions that are given. All we need to do is just be careful. We just need to be careful on which side should be or which sides are equal. Okay, because especially if it's isosceles triangle, okay, sometimes the two sides will be given in the problem itself. It might be like, find x and the measure of the unknown sides of isosceles triangle EFG, given that EF is congruent to FG, like that. So the problem itself gives you the hint on what sides are equal, or what equation to write. Sometimes you're not given with a statement that says EF is congruent to FG or EF is equal to FG, but it would also tell you that, like, F is the vertex angle. So when you say F is the vertex angle of an isosceles triangle, then it means that F is the angle that holds the two equal sides. When you look at here, EF and FG are equal. So the common letter is F. So since F is the common letter, that means angle F or vertex F or point F is the vertex angle of isosceles triangle EFG. Okay? So next, we can also have problem that involves, again, distance formula, your favorite distance formula. So for those who are not yet serious of understanding the distance formula, I don't know what to do with you guys, but like what I've told you before, we will be using distance formula this whole semester. For those who understand the formula, who put in time and effort in understanding the formula, when we had the classwork in 1-6 and the lesson, every time there's a lesson using distance formula in the classwork, they are the ones who really give a very high high score in their classworks, because the distance formula are gives you a lot of points. It requires you solution. So every time you have solution, this is a math class. So once you have a longer solution, then that means it's equivalent to certain points, not only 1 point. That's why when you do your classwork also, You have to write all your solution. You don't just give me a classwork that says EF is 5 square root of 2 without any solution. What information would it give me? Okay, it gives me an information that you are just copying answer from somebody, unless I see you before that you are really doing the classwork and you have just had this classwork that you don't have solution. I might think, oh, maybe it's on the other piece of paper. But for most of you who just turn in a classwork without solution, I don't know if you understand that you are in a math class or you might be in other subjects. So please, if you do classwork, write all the necessary solutions that enables you to arrive at your final answer. So again, here, how do we use the distance formula? We use the distance formula here to find the measurements of the side, because we are going to classify the triangle based on the side. So we are just concerned if there are two equal sides, if all the sides are equal, or there's no equal sides in the triangle. Okay, so you have there EC is square root of 50. DC is also square root of 50. ED is square root of 100 or 10. So looking at the three answers, we found out that there are two equal sides. Okay, and so therefore, since EC and DC are equal, then we conclude that triangle DEC is an isosceles triangle. Okay, you might ask, teacher, where does those numbers in E and C and D came from? We don't see any number -5, 3, -2, -2. Those are from the coordinates of E, C, and D. Okay, because the author of this book already assumes that you already know how to identify ordered pairs because you've been through your lower math course already. I mean, you've gone through Algebra 1 and Algebra 2, so you're expected that even if you're given with this graph, you already know how to get the ordered pair. Okay, for review purposes, let's identify each pair. Okay, because you might just spend a minute or two sending me a message on Messenger just to ask teacher what is point C. Point C is the x coordinate is +2. See, from 0, 1, 2. So we put +2. First number is always x, and then the second number is y. So going up from 0, it's 1, 2. So C is a 2 and 2. Okay, what about D? D, so 1, 2, 3 is the x. And then the y is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's +3, +9. Towards the right is positive for the x. Going up is positive for 9. Okay, point E. What about point E? Okay, you see point E, the x is from 0. We have to go backwards from the 0 to the left side. So we have to count by units 1, 2, 3, 4, 5. Since it's 5 units and to the left, that is equivalent to -5. And then going up 1, 2, 3. That's +3 units. So now that's the reason why we have those numbers there in the distance formula. So you are given with these numbers, it's time for you to understand the distance formula. Okay, so this will be the focus of our lesson today. So two things: solving problems involving the variable x. So either you're given with an equilateral triangle or isosceles triangle. So how are you gonna deal with that? So if you're given with an equilateral and isosceles, I mean equilateral, you can select any two sides and put equal sign between them. If it's isosceles, you have to be very careful to select the two sides that are equal and then write an equation out of those two sides. For coordinate geometry, if you're not given with ordered pair, but you are given with a graph, you need to identify the ordered pairs of the points, and then you do distance formula for each side. Okay, but if you're given with the vertices like this one in the check your progress number 4, then it's easy for you to do the distance formula. You're just concerned of whether there are congruent sides and how many sides are congruent, so that you can answer what kind of triangle you are presented with: isosceles, equilateral, or scalene triangle. Okay, so that's all for today, and I hope I'm gonna see you later on for our Zoom discussion.